Let's do an example in which we perform the 5 steps of hypothesis testing. In this example, we test a claim about a proportion. In the next video lecture 6, we will test claims about population means. We tossed a coin 100 times and 37 of these tosses were heads. The claim that we want to test is the coin is biased towards tails. That's the exercise. Alright, so step 0, first we identify the population parameter. Well, in this case, that's the population proportion of heads, and we call that one P. Then in step 1, we formulate the null and alternative hypothesis, and we choose a significance level alpha, or actually alpha is in the question, but you have to formulate your null and alternative hypothesis. The claim is the coin is biased towards tails. This is what is contained in the alternative hypothesis. So if we translate this claim, this means that the population proportion of heads is less than 0.5. So that's the alternative hypothesis. And then the null hypothesis is P being equal to 0.5. That's always how this works. So this is our null hypothesis and we test it versus the alternative hypothesis. And let's do this with significance level alpha equal to 5%. You never have to come up with it yourself. This is given in the exercise. It's very important that you get these hypotheses right. So let's have a look at some other examples. If the claim is that more than 60% of students have a Snapchat account, this is what you put in the alternative hypothesis. So the population proportion is then greater than 0.6. And the null hypothesis is always with an equal sign, so P being equal to 0.6. Because the null hypothesis is what you try to reject. And we want to prove this, so if we reject this, then we have evidence that this is true. 20% of Dutch citizens support Forum voor Democratie. That's a Dutch political party. The null hypothesis always contains the equal sign, and in this case the alternative hypothesis is P being unequal to 0.2. This is a two-sided test because the claim doesn't say anything about more or less than 20%. Less than 35% of women smoke. So then again in the null hypothesis, P is equal to 0.35 and the alternative hypothesis is that P is less than 0.35. So we did step 0, step 1, let's go to step 2. That is about collecting data. Well, you don't have to do that yourself in this course. It's also given in the exercise. 37 times heads and 63 times tails. Now in step 3, you have to choose a test statistic and identify its distribution under the null hypothesis. We know that a sample proportion approximately has a normal distribution. The mean of this normal distribution is equal to P and the variance is equal to P times 1 minus P over N. We have seen that a couple of times now. We can use that to construct a test statistic that is standard normally distributed and therefore does not depend on P, which is important. So the sampling distribution of our sample proportion has this normal distribution, and therefore if we subtract the mean from the sample proportion, so minus P, and we divide by the standard deviation, so the square root of this variance, then we have a test statistic that has a standard normal distribution. And we identify its distribution under the null hypothesis, so under the assumption that P is equal to 1/2. So that is the value that we substitute here and here in this test statistic. The next step is to use our data to compute the value of our test statistic. So from the data we know this value. This is 37 out of 100, so this is equal to 0.37. And therefore the observed value of the test statistic is equal to 0.37, you can substitute that here, minus 1/2 divided by the square root of 1/2 times 1 minus 1/2 is also 1/2 divided by 100, that's n. And when you compute this, you find that the observed value of the test statistic is equal to -2.6. So this is our observed value of the test statistic, and now we're going to compute the probability that we would find more extreme values than this value. And if the probability is very small, that means that our observation is very unlikely under the assumption of the null hypothesis. This is called finding the p-value. We have observed a test statistic value of negative 2.6, and now we want to find the probability of the test statistic taking even more extreme values. How to compute this probability depends on the test. In this case, the test is left tilt. Our alternative hypothesis was p being less than 0.5. We have found an observation of negative 2.6, so now we have to compute the probability that our test statistic is less than or equal than that observation, so that it takes even more extreme values. Extreme values in this case means values less than or equal to negative 2.6, because our test is left tilt. So we compute this probability. So we go to table 2 and look at the z-score of negative 2.6, and then you find the corresponding probability of 0.0047. And now we can conclude. This p-value is smaller than the significance level alpha, because alpha was 5%. This means that the null hypothesis is rejected. We have enough evidence to confirm that the coin is biased towards tails. Okay, so it's good to know that if your test is left tilt, so if the alternative hypothesis is that your parameter is less than something, then the p-value is the area to the left of your observed test statistic value. And if your test is right tilt, so if the alternative hypothesis is that your parameter is greater than something, then the p-value is the area to the right of your observed test statistic value, because that's then where the more extreme values are. Of course, your test can also be two-tilt. That is when your alternative hypothesis is that your parameter is unequal to something. If in that case your observed test statistic value is less than 0, then the p-value is 2 times the area to the left of your observed test statistic value. And if it's larger than 0, then the p-value is 2 times the area to the right of your observed test statistic value. And then when you have your p-value, if it is less than or equal to alpha, we reject the null hypothesis. And if it's greater than alpha, then we do not reject the null hypothesis. Let's do another example. This is about left-handed people, and the claim is that 10% of the population is left-handed. This is a two-sided test because it does not say more than 10% or less than 10%. Okay, and some data is given. We have 750 people in our sample and 92 are left-handed. Alright, so let's test this claim following these steps. First, we identify the population parameter. In this example, that is again a population proportion, and we will call that one P, the proportion of left-handed people. Now we write down the null hypothesis and the alternative hypothesis. This is a two-sided test, and a null hypothesis always contains an equal sign. So the null hypothesis is P being equal to 0.10, and the alternative hypothesis is P being unequal to 0.10. And in this question, it is given that the significance level alpha is equal to 1%. You don't have to come up with that yourself. So then we collect data. Well, data is always given in the question in our case. So we know that 92 out of 750 people are left-handed. But this is the right order of these steps for the researcher, because the data should always be collected after the researcher has defined the null, the alternative hypothesis, and the significance level. It's not allowed to change the significance level at the end of the study. Then you manipulate your results. Okay, so now we have to think about the test statistic. Well, this is again about a population proportion, and we know the sampling distribution of the sample proportion. And we can again change that into a standard normal test statistic. So we use again this test statistic. And under the null hypothesis, this test statistic has a standard normal distribution, so it does not depend on P. And well, n is large enough, of course, because n is 750. So now we can substitute all these values. So the observed sample proportion is, 92 out of 750. So we can substitute that here. And then we substitute P. And we find that the observed value of the test statistic is approximately 2.07. So now we can compute the corresponding p-value. This test is two-sided and the z-score is greater than 0. That means that the p-value is equal to 2 times the probability that our test statistic is greater or equal than 2.07. So we go to the table and we find this value, but then this is the probability of z being greater or equal to 2.07, so we have to take the complement 1 minus this probability because we can find this probability in the table. This probability is equal to 0.9808, and then 1 minus the probability is equal to this, and then 2 times, then this is our p-value. This p-value is not smaller than our significance level alpha, because alpha was 0.01, 1%. So that means that the null hypothesis is not rejected. We do not have enough evidence to confirm that the percentage of left-handed people is unequal to 10%. This is a correct conclusion. Be careful, you cannot conclude that the null hypothesis is true. You do not say that we now have proof that the percentage of left-handed people is equal to 10%. That's not the conclusion of a hypothesis test. The conclusion is either we reject the null hypothesis and therefore the alternative hypothesis is true, or we do not reject the null hypothesis. Note that if our significance level would have been 5%, then we would have rejected the null hypothesis.